on this computer. So welcome everyone to our Cyberops class. So this is 938. And so we're talking about down here at the very
Last
bottom.
one.
So everything worked until you got to right.
Everything worked, yes.
Okay. So scanme.nmap.org. Scan
That's one work.
me.nmap.org.
That's one work for my last one.
Oh, that is the last one.
No, not this one. This one.
The B?
Yes.
Okay. I was just making sure this part worked because it's not working for me. Scanme.nmap.org. So let's see. Let's go to the workstation. I'm gonna undock this and put it right here. Oop, I can't put it all in. I got two monitors now, so I can have to kind of completely here. So let's go down. So this part worked, the scanme.nmap.org worked, but the
because I use my machine.
right.
Yeah, so it is work for my machine. But when I try to do the terminal, it is not working.
Okay, let me see. Let me make sure there's not a need to be in a specific folder for this to work, because I think there is. It has to be, you have to be in the desktop folder.
Oh, maybe that is. Yeah, now I get it.
I bet it will work now, but let's just try it to make sure.
I didn't pay attention to that.
Well, that's okay. It probably had you using a folder you had opened earlier, but
yes.
If it didn't,
yes.
You could have opened it. If you opened a new one, it may not have. You may have been in the wrong folder, and that's why it didn't work. But let's make sure this works. T4 dash T4.
Yeah, it will work.
Nope.
No, same message I get from my
Okay.
one.
Here, there's nothing on. Let me check, make sure there's nothing in. Yeah, I'll have to look and see what's going on with this. There's something, for some reason, there's just not the file there. It should be showing you these open files. Should be scanning, actually should be scanning a machine that's in the background of this setup, but for whatever reason, it's not working. Oops, wrong thing.
Yeah, same message I received from when I try, but I didn't have the desktop.
Yeah, it's just the Nmap's not finding the. It's not finding that scanme.org. Let's try this. Let's do a CD desktop. Okay, let's do a ping scanme.nmap.org because I would think it would. Temporary failure. Okay, so it can't do. So for some reason, did anybody else have this issue? Ralph, did it work for you? Or have you tried this one yet? Okay, there's that one, scanme.nmap.org, but it should have told us. What you should be seeing is at port 22, 135, 2580, 139. Basically, all of these ports are open. And for whatever reason, it's not showing you. Some of them are filtered, some of them are open, so some of them are being blocked.
Hey, Kelly, to be honest with you, when you said 25 labs, I went to the back and worked my way up and started, I think it was in like chapter 10, I started doing all those.
Right.
You know, when it really started getting into like Wireshark and the good stuff.
I don't have Nmap locally. if we had a machine that was on our regular network, this would work. This scan would. So don't worry about it right now, Uzma. But what it is, it just can't find this host.
Okay.
I mean, that's exactly what it's telling you. It's telling you it can't find that host because it's saying it can't resolve it and can't find the IP address. So for whatever reason, this particular lab, I'll investigate what's going on, but it just can't find that particular part of the lab itself. And it's scanme.mmap.org. Scanme.mmap. Yeah, I got it right. It's not resolving. So I have to do some troubleshooting to figure out why that's not working. But the big thing is you understand what Nmap does and how to use it and what its purpose is.
Yes.
Okay, that's really the big part of this one. If that part didn't work, then that's not the one little part didn't work. It's just showing you that as long as you understand how it does work, then we're good to go. And what it's for, that it's for to scan open ports and to find out if ports are being blocked by a firewall or if what's open, what can be. It's used mainly now. In what part of the attack phase would this tool be used in? Where will we use Nmap? What would be our typical area we would use this type of tool? Say we were hired to do a penetration test on a company. We would want to use this tool as part of our reconnaissance to start looking to find different open ports and things. The only thing I will tell you is this: it's a very loud tool. Nmap scans are very easily seen by intrusion detection and intrusion prevention systems. So do be aware of that. They are easy to see happen. Okay. So, but that's what's going on with that one. That's why it's not that one little item. It can't find that scanme.org, which it should work because here it is. Go ahead and scan me. So we can actually scan this. If we had Nmap log locally installed, we could scan it and it would work fine because you can actually scan using this. So, all right, let's talk a little bit, folks, about, I'm going way down here into the 26 because I want to talk a little bit about what's going to be on your hands-on test and the parts of that hands-on test that you're going to be using. And what we're looking at is we have Security Onion. So at this point, as we're moving into the second part of the class, you would have installed the second virtual machine in your local environment. If you're doing things locally, you would have put the Security Onion in. So you have the workstation. You're going to have a Windows box to do labs on. And then you have the Security Onion, which is part of the open source network security monitoring tools on an Ubuntu Linux distribution. Now, I know the one we have is not the most up-to-date tools, but it's the ones that we have available to use in this class. So, there are up-to-date tools that are a little bit more up-to-date than what we have, but this is still good for what we're trying to do with our students. So in the Security Onion architecture, what you have is Squeal, which is sitting up here at the top, and that's basically it's a monitoring tool that can bring in information, an analysis tool from a lot of different areas. And so along with that, we have Wireshark and Cabana, and Cabana is a tool that takes Elasticsearch information and can bring it in. So really what happens is this: we have all this data at the bottom that comes in from various sources, and that data can be found from a host log. It can be found from IPS, IDS alerts. It can be found from any of these items down at the bottom. A lot of times that is brought in by different detection systems like Snort, Zeek or Bro, OSEC, Cicada, okay? And I don't know, it's a network intrusion system, a system similar to Zeek. Wazoo is a host intrusion detection system that will replace OSEC and Security Onion eventually. And OSEC is a host-based. So all of these are tools, these detection tools that find this data and feed that data up to Squeal. And then Squeal can use Wireshark and Cabana to do all kinds of things to pivot and to find information about different types of attacks. So this Squeal is a high-level console for investigating security alerts. We're going to look at it here in a few minutes. We're going to do 2 labs today. I'm actually going to run you through 2 of the labs as part of class today. You got Cabana, which is an interface for Elasticsearch data. So you can query the data and provide visualization of data. I had some problems finding a couple of areas they were trying to get us to find. So that's why I'm gonna run through one of the labs and show it to you, because it's also very similar to what you'll be doing when you're doing your hands-on. Wireshark, we've all used Wireshark before to capture data, to get Pcap files, and also to look at Pcap files. And what we're going to do today is we're actually going to extract a file from Wireshark using the ability to extract a file. Zeek Network Analyzer used to be called Bro, but they renamed it Zeek. So Zeek or Bro, you'll see it named both at times, but now the official name is Zeek. But we get alerts that are generated, and typically those alerts have the 5-tuple: source port, source IP, destination port, source port, source IP, destination port, destination IP, and protocol. So those items are used as part of the information with every alert. And then you get a count on the alert here in the squill window. You see the alert ID, when it occurred, the source and destination IP, source destination port, and the event message, so that you can see what is being fed into it and what the data is trying to tell you. So status RT means real-time event. Count, the number of times it's been detected. The sensor, that's the agent that gave you the information or found the information, or had this information came from. The alert ID, so it reports the problem of the number of the event. So we can seem to figure that most events are from the OSEC sensor 1, and it's reported 8 sets of correlated events. So you can actually find different events that are related to one another. So the devices are on the left, and then the dots are the associated events. So 9697, those are events that are associated or related to each other. Date, time, and event message. Now, as we look at the bottom, a lot of times there is a way, especially we're going to see this in our example, to do show packet data, show rule. When you do the show rule, it tells you what rule from your device fired off this particular alert. So you'll typically see, by seeing the packet data in the show rule, you'll see that this is TCP from any external network to any home network that attempts to use this backdoor user login smiley, okay? And then it's got other information about what this particular rule is. But this is the rule that caused this alert. And that's how we'll show you more about that as we get into Squill here in a minute. But you also can see the snort rule, if there was a snort rule instead of a different type of rule. Here it is: alert IP any to any. So any source to any destination, GPL attack response, check return root. So this is saying somebody has used or gained a root privilege. And that is obviously something that could be a major issue if it's a Linux box that's being attacked. And then that's the snort rule structure. And here's the rule header structure, again, talking about pretty much the same thing. I'm looking at the different types of rules. Some of the rules were back in the day when Snort was created by SourceFire and distributed under GPL. So sometimes you'll see GPL order, the rules are listed differently, but all of them are very similar in that they give you the source destination, IP, and port, and then what the actual message is, the reference, okay, class type, category of a type, and then a unique identifier for the rule. So that's the SID for the rule. One of the things you will learn down the road as you play with IDSs and IPSs, especially with Cisco IPSs, what if you have a rule, and now this rule I probably wouldn't stop, but what if you had a rule that was consistently giving you a false positive and you knew it was not a false positive? What would you want to do to that rule on your intrusion detection system? There's a couple options. What's one of them, Ralph?
I'd either change the rule, ignore the rule.
Yep. Now, if you ignore the rule, that, it's kind of like, are you going to fix the problem with a hammer, or are you going to fix it with, you're going to fix it a little bit easier than that? A hammer would be just turn the rule off. Just turn the rule off. Okay. But another way, like you said, is fix the rule. So in other words, if this would be the rule, let's say, and I was getting this every time I logged into one of my machines from my management box to my Linux box, I could change this to allow those two machines to not fire this rule. So I can modify the rule. So there's ways to modify the rules. There's ways to turn the rules off. Okay. Now, as we look at these, the primary tools for a tier 1 cybersecurity analyst that we are dealing with. Now, this is not true in the entire world because there are other tools out there that are in use by other SOCs, and you'd have to learn their tools. But Squill is what we're going to use, and we're going to use Cabana, Zeek, and Wireshark as our primary items to look at different alerts and determine if it is actually a problem or not. Now, this is where we get into a true positive. So a true positive is an alert that is verified to be an actual security incident. A false positive is an alert that is not an actual incident. A true negative, no security incident has occurred. This activity is benign. And a false negative is probably the worst possible item you can have. A false positive we can tune. So we can go and say, hey, that really is not an issue. That shouldn't be going off. We can fix that rule. A false negative, we never knew they were there. Okay. And so this is probably the absolute worst possible thing we can have from a security standpoint is a false negative. Now, a lot of times that's why when we design our systems, we are very, we tighten them down really tight. And then we look at all the different positives and false positives, and we slowly take our system and we tweak it so that we can have what we need. So true positives are desired. False positives are obviously not desired, but they can be worked with. False negatives are dangerous. They're just completely dangerous. So let's look at, let's actually look at a couple labs. So we're looking at a couple things here. Let's go back to my labs. We're going to look first at extracting from a Pcap. So this particular lab has you looking at a set of pre-made Pcap files. So this, in other words, this is a capture that's been made in the past. And so we're going to actually go into the lab support files Pcaps folder, and we are going to let me see if I can do this. Let me see if I can take this and slap it over here, and this one will be there. Okay. So we're going to do, and let me, folks, I'm going to turn off. Actually, I'm just going to move me over to this other page over here. So Cyberops. Password. Yeah, if I type it in correctly. By the way, has anybody been having any trouble with our labs? Does it seem slower than normal?
Your net labs?
Yeah, net labs. Does it seem slower for you?
Well, I do it usually like 11 at night, so
Right.
it might just be me on there.
Well, we've had a couple. We are doing some changes to our network. By the way, our changeover Friday blew up in our face. It did not work. So we had to. We didn't do it, but the designers of the network took the network down. So we had to back up and punt. And so see, yeah, there's something going on with our. We should not be having. But I'm also on this, and I'm at my house, and I have very slow internet. So see if I can do it. All right. All right, so now if I do an ls-la, we should see a NIMDA download in here somewhere. Am I in the right place? Oh, I didn't go to Pcap. Okay. Yep, there's the NIMDA. Okay, so we're going to start Wireshark. We're going to get the NIMDA download Pcap. Okay, and we're going to start it up. Sorry about my phone, folks. So we'll get this started, and it will load for us the Wireshark. Now, what we have here is a capture of a file that is NIMDA, which is really not NIMDA. But you see the three-way handshake here, send, send, ack. And one of the very first things they have you do is they have you follow the TCP stream. So you basically click at the very first here and go follow TCP stream. And this will let you see get NIMDA 32. It goes down through here and you see you're getting it from Nginx, which, by the way, that's the most used web server on the internet today. There was actually recently a big security problem with it. The lab asks you, why do you see all of this weird code in here? Why is that? Anybody know why we're seeing all that? All this junk in here? Did I lose everybody? Let me
Yeah,
come.
I'm trying to think, is that like the page we asked it for, or?
Well, it's because we're getting a binary file. So this is Wireshark's attempt to figure out what all that binary code is. And so it's just feeding you gobbledygook. Now there are some text messages in here. So like at the very end here, notice that this really isn't NIMDA. What is this? Look at what it is. This is actually, the original file name was command.exe. So someone just named command.exe NIMDA because they were not crazy enough to put NIMDA on a machine and take chances with it. But if this was not, a benign CMD file, you could gather some information by looking at the text in here that you would get and see if there's any type of information that gets left over by following the stream. So that's really the first item there they want you to do, is just look at the stream and then do that. But then you can also see here, as part of this particular Pcap, we're trying to get this NIMDA, NIMDA.exe. So we can actually go, if we've got the capture of the entire thing, we can actually go to File, and we can go Export Objects, HTTP, because it's an HTTP connection. And we can see we can export this NIMDA.exe, NIMDA.amm.exe, and we could save it. And so we could save it into our Analyst folder. We could save it on our desktop, downloads. Let's just put it in downloads. Okay, we'll save it there. Now, normally at this point, now that we've extracted it, by the way, let me go through that again, because one of the things you must do for the exam for this class is to know how to extract a Pcap, a file from a Pcap. So what you do is find where that file is being brought down, and if it's HTTP, you go File, Export Objects, HTTP. If it happened to be a TFTP file, you can do it with TFTP or SMB, but then you can save that file. Now you'll notice if I go in here and I do a CD downloads, you'll see that NIMDA 32 NIMDA.am w32.nimda.amm.exe is here. So we have extracted that locally. Now, what we would normally do at this point, if we were truly in computer security, is we would take this file. First off, we would have never extracted it on a machine that had access to our network. This machine would have been isolated from the network, would have no network capability at all. It would be a Pcap file that we brought in here, and we'd make sure it was isolated. Then we would take this file and we would run it, we would play with it, we would see what we could learn about it in a controlled environment. You would never do this. Oops, I shouldn't hit that. Okay. So this just tells you this is an executable file for MS-DOS, but you would never run this anywhere that it could make a dangerous thing. But as a security analyst, our next process would just be to examine this file in a more than likely virtualized environment to see what it would try to do. We'd be looking at it. We'd probably have several machines running in a sandbox so that when we ran this file, what does it try to go out and connect to? What is it trying to attack? But all of that is just by taking a simple Pcap file, finding where that file was originally downloaded, and then extracting that file from the Pcap file. Now, again, one of the main things it says in one of your exam goals is that you must know how to extract an executable from a Pcap file. So right there it was. Find the executable you want to extract, file, export objects, and then pick the correct protocol that was used to originally gather that object. All right. Questions about that? Pretty simple process. Actually, a very simple process. All
And
right.
you would do that from the get in the Wireshark, right? in the Pcap?
Correct. Yep,
Okay.
from the get. And this one's really clean because this was literally started and ended when there was just one file, only one file was pulled in. So it may be in the real world, you'd have to clean it up a little bit and get the TCP stream together that had multiple files that were in here together, and you just pull one stream out, and then you would do it that way. So that's why they did you do follow the stream. You can actually follow TCP stream so that you can pull in just this one stream, not all of the information. And you could even save it if you needed to. But the main thing is find the get. Now, imagine if it was TFTP, it was a TFTP you may have to use instead of the get. It would be the TFTP put or copy, or the command that was used to get the file from TFTP. But I think the actual even exam objective says from HTTP. So pretty easy thing to do. Questions about that? I want to show you that one because that's one of the ones that's pretty well known. See, Clay's working on some multi-protocol BGP, which I need to tell him not to worry about that. That's not actually part of the exam, but. So I'm going to end this one so that we have those resources back available for somebody. Now let me go look at this other lab I wanted to talk to you about. This lab is isolating a compromised host using the 5-tuple information. So you'll see we're in the security onion. So we're going to go ahead and I'm going to undock the content. And I'm also going to take this and put it over here, put content over here. We're going to log in with our normal, which is just Cyberops. It's Analyst. And we're going to do Cyberops to get us in. Now, once we get in here, you've got to start squill, and it's on the left-hand side of the security onion. It's just a application you start. So in this particular attack, the users no longer have access to a file named confidential.txt. You're going to review the logs to determine how that file was compromised. Obviously, you would not use the passwords analyst and root in a real production network, but we're doing that for simplicity's sake. So here, again, you got to open Squill, and then you have to log in. By the way, there is an entire page on Squill if you want to look at it. I still like saying they call it Squill, but they call it Squill. It's my personal, but we do analyst, and then Cyberops, which by the way, I mistyped this password earlier today and I was like, what in the world? Now it's important here. If you miss this, it will mess things up. Don't forget to say select all. Otherwise, it will cause problems for you because it won't pull in some of the information that you need for the particular labs that you're doing, especially once you start doing your hands-on final. So looking at the interface here, you can see that the interface shows you these are real-time events, the number of counts. On the right-hand side, you can see, oh, my internet connection is unstable, so hopefully it'll. Okay, can you still hear? Everybody still hear me?
Still hear you.
Okay, good. So on the right-hand side here, you can see the different messages. Okay, so what they're wanting us to do here is to find the one check ID return root. And if you show your packet data and show your rule, you can see the actual rule that was hit to make this particular event go into the event log. So alert IP any message GPL attack response ID check return root. So somebody has been elevated or has root access somewhere. You see the source IP is this 209.165.200.235. Destination is 209.165.201.17. Now, for us, those don't really make any real sense because we don't know what those servers are. If this was a real network, we could know and query what those machines are, and we can know that these machines are, probably servers in our server farm that are, just letting us know that this particular host 235 got root access on 17, and maybe they should have root access, maybe they shouldn't. And then on down, this actually shows you the actual data itself. And it says the the root ID or the ID was root. All right, so there's that. Now, you can also look here and looking at the event itself. So alert ID 5.1, which is here, and you can right click on it and you can go actually do right on it and do transcript. If you do a transcript, it will pull up information telling you more information about what happened here. So the source ID, destination ID, and you see here OS fingerprinting, told you it's Ethernet, going down, but this tells you what commands were run. And you'll notice as we're going down here, we'll see who am I, root, hostname, metasploitable, if config. So they first found out what their IP address was. So 235. You also will see down here, they're going to be doing some nefarious things. They're looking at the shadow file. So they're trying to look at password files. And then they also on down here export that shadow file and the password file. So they're trying to find the password file and the user information on this particular system and export it from this system. So this is pretty nefarious looking here. So you've got them executing those Linux commands, and you can see them attempting to grab information from this particular Linux box. We then have the ability to pivot to Wireshark. So what we can do now is instead of looking at this one, we can look at this particular information. We go to the event ID and we can go down to Wireshark and we can pull up a Wireshark. And you can click OK right there, it's fine. But you can pull up a Wireshark Pcap that is associated with this event. All right. And then now you can right click and let's follow the TCP stream again. So we're going to look at the TCP stream and see what we learn about this. So we can see that, okay, so they're echoing who am I, root, hostname, if config. This shows you them running the configs again. They ran if config, this is what they got. They catted the shadow file. Okay, so that's the command that the hacker was sending, and that was the response it got, was the shadow file. And then on down, they echoed that file. So now they copied that file. And now they've catted the password file, and then they echoed that file, trying to echo it locally too. So they're copying it to their machine. Okay, so they exfiltrated two things, the shadow file and the PSSWD file, which is pretty dangerous. Now this is where things got a little bit funky, but not too bad. And that is you can now pivot to Cabana. Okay, so there's a couple ways you can do this. The one that, let's see, right here, you can right click, and we could have just done it. We can just right click right here, and we can go Cabana IP lookup. Oh, I'm about to drop something here. Cabana IP lookup, and we can do source IP. So we're going to look at anything that Cabana can find that is from the source IP of 235. And you just have to say, yep, it's okay. Don't worry about it. And you got to log in as Analyst and Cyberops. Cyberops again, our basic logins. And now we're going to log into Cabana. And this does show you where the age is getting a little bit high on these on this particular security onion that we've got, because you've got to change the absolute time range to get it back to 2020. So instead of if you look at last 24 hours, you'll never find this attack, because if you'll look, it was way back in 2020. So what you have to do is go click here and you go absolute, and then you can go all the way back. And this, you just do it like this, just click back to 2020. And if you want to make things simple, you could just say June to July, but you can just click here, absolute, and click go. And you'll see that you're going to get information here in a second. You'll notice it's actually running across here. Well, it was. Oops, I messed up. I did the wrong date. Notice I didn't get any data there because I didn't put the right thing in. So click here. go. So now it should be June. I did it again. Goodness gracious. June 1st. There, now go. Helps if you click the right thing. So finally, I've changed this absolute to June 21st, and there should be just a couple things you see here. Okay. Now we've got more than what they're showing, but that's fine. But you'll see you're told that confidential file is no longer accessible. We're going to determine if FTP was used to steal that file. So what we can do is we can scroll down here and look for bro FTP. But remember, that's where Zeke tried to find things. Now, if you want to filter just for that one value, these two items that bro saw in FTP, it's hard to see, but that's a plus. So click that plus. And once it applies it, you can scroll down to the all logs section. So now you'll see it goes to 2. You can scroll down to the all logs sections, and you will see, as we get on down here, you got to scroll all the way to the bottom. You know, so there was 2 items that took place, and this was the source IP, destination IP. So you can see from 192.168.0.11, destination that went to 235, port 21. So if we expand here, and then look right here under the ID, we will see that CapMe pulls this and says, it pulled the file confidential.txt. Okay. So the file confidential text right here was removed from our network, okay, as part of an FTP that took place on that particular day. Now you can even see the contents if it was captured, and it's not always going to be captured, but in this case they did capture it. So you can go to your files, you can go to the FTP data, eventually if it ever. FTP data, click 1 here, and then you can actually see, once you scroll to the bottom now, get to the very bottom here and expand it. If that file had been captured as it was being exfiltrated, which it was, in this case, it should show you the contents of that file, which it says confidential document, do not share. This document contains information about the last security breach. So that shows you what was in that file itself. So we were able to take from Squeal, Wireshark, and Cabana, and we were able to look and find through all of this the information about first, someone gained root privileges, and then using those root privileges or having root privileges, they were able to gather information that let them get the ability to download this confidential text file from another box in our network. This lab 27214 is going to be the one you really need to concentrate on to help you with your hands-on final for this particular class, because it's very, very similar to what you're going to be doing as you look. And one of the things I want to warn you about a great deal is, like when you're in Cabana, be very careful about the dates at the top, because if the dates are not set right, if you're not looking for where it's saying, then you won't see the information that the lab's wanting you to look at. So just be very careful with that, okay? Questions about these? These labs are, go ahead.
Now, there's a lot of information, and part of what I thought was funny was Wireshark, where it was telling you like he's running the the who am I command, root, the host name, all that kind of like to learn what the heck he's got.
Mm-hmm. And to see what they've got now. And I will be honest with you, probably real world, they're not going to do as much of that, because they're going to know they're going to know the command that they ran gave them certain levels of access. But still, you would be able to see, someone getting root access, someone using root. At least that would be, because you see here that this is just looking for, this is check return root. There's other things like if you log in as root, there can be an alert that shows up. You know, there's all kind of things in here in terms of different attacks here. Here's a, let's see, where's that? This is, let's see, where's that one I just saw a second ago? There's all kind of stuff about trying to find or certain Trojans being attempted to be loaded on the machines. There's all kind of ransomware check-in. Yeah, it says, yeah, see, this is a Trojan that was trying to check in with its control center. So yeah, there's all kind of cool things they put in here for you to see. The hands-on final will lead you, it leads you pretty easily through. You know, the attack we know took place during kind of this time, and so you need to look in this time frame and see what you found. And it's not hard to follow, but it is neat how Squill takes all this information, as we talked about in the course here, as we talked about, you know, looking at, where was it? Right here. As we looked at how this Squill takes all this data that's down here, filtered through these detection systems that use their rules to eventually pass that information up to Squill, and then Squill can use Wireshark and Cabana and other things. There's other underlying items that could be used to help you as a level 1 analyst figure out exactly what was going on in the attack. And then pass it up. Typically, what your job as a level 1 is, you're going to pass it up, you know, to level 2 and say, hey, we've got something going on here. We probably need to figure out what's going on. And then they can make a decision about going from there. But I think it's neat to see it all working together the way it is. It's pretty cool. Okay. Questions about what we just went over today? Any questions at all?
No question. When I will do the lab, then I will ask question.
Okay. I was looking, our class, technically, this class ends the 26th of April. We will not have this class next Monday because, no, not next Monday, be the Monday after, because it's Easter Monday. So we will not have it in 2 weeks. I do plan to have it next week, even though I will be at a meeting in, I'll actually be in a meeting in, at Forsyth Community College for the Carolina Cyber Network, but we will still have our class meeting. I may just have to do it on the phone, but I'll be there in case you need anything from me. So
I will email you. If I have a problem, I will email you. Okay.
That'll be fine. That'll be fine. No problem at all. Definitely email if you do have questions. So I'm gonna stop the recording.